Hi, welcome to my video on maximum minimum word problems, part 4. These are a couple of extra problems that I made up to finish off the maximum minimum word problems, and they're called just extra. A rectangle has dimensions of 60 by 40 feet. Its length is increased if the length is decreased by a certain amount and the width is increased by twice that amount. Find its maximum area. Well, we have the length is 60 and the width is 40 feet. And as if the length is increased, so we're going to let x be the amount of decrease or increase, and amount of increase or decrease could be either or. The amount of increase, decrease. Here we go. So it says if the length is decreased by a certain amount, so the length is 60 and is decreased by a certain amount called x, and it says the width is increased by twice that amount, so the width is w, and if the width is 40, it's going to increase by twice that amount, which is 2x. And as a result, we want to find the maximum area. Well, the area of a rectangle is length times width. So if the length is going to be 60 minus x, and the width is going to be 40 plus 2x, we want to find its maximum area. So the area is 60 times 40 is 2400. 60 times 2x is 120x. Negative x times 40 is a negative 40x. And a negative x times 2x is a negative 2x squared. And we rearrange with x squared first. Add up the x's, and I get a positive 80x plus 2400. So the equation is A, area is a function of x, and x is the amount of increase or decrease to each of these. So as a result, we have a quadratic, and because it's negative, again, we have a maximum, means the parabola is, or the rectangular area, I say parabola, but it is parabola shape. So the width and the x is the amount of increase, so this is the amount of increase, and we have going up here area, and this gives us a vertex. So we have x equals negative b over 2a. A is negative 2, b is 80, c is 2,400, and that gives us a negative of 80. 2 times negative 2, negative 80 over negative 4. So x is 20. So x is the amount of increase of 20. And it says find the length and width that will give you the maximum area. So since we have x, which is, this is x right here is 20, and the height or the area is the vertical distance up and down here. So we want to find what the area is. So to get the area, we will sub the x of 20 back into this equation and figure out what a is. So the increase of 20 and the decrease will be found by subbing into this equation. We will get the area. Again, it's like a vertex. The vertex is increase, decrease x, and an area. So we have what x is 20, sub it in. So we get 400. 20 squared is 400 times negative 2 is negative 800. 80 times 20 is 1600 plus 2,400, and that's 800. So that's all together added up is 3,200 is the maximum. This is the maximum area is, and the area is in square feet. Again, if think about it, we have 60, and its x is 20, and we have the width, which is 40, increased by twice that amount, so 20 times 2 is 40. So we have a 40 times an 80, and that gives me the 3200. And just to explain that, let me do it in another way, just see if this makes sense. If I say that's the width, and I have x, and I have the length, L is the length, x, and the length decreased by x, and then I have the width, and I have x, and the width plus 2x, then I'll have an area. Let me explain. Let's see if this makes sense. We did it this way and everything worked out, but let's see. Let's say the length is 60 and there's no increase, so we have a 60, and the width is 40 and we have no increase, so that's still 40. So the area is 60 times 40 is 2400. Now, if the length is 60 and we take off 5, that means 60 minus 5 is 55. If the width is 40 and x is 5, we have to double that, so that gives us 10. So that means the new length is 50. And 55 times 50 will give me 27. 55 times 50 is 2750. Just check with your calculator and you'll see that everything comes out okay. I'll just check with the calculator now very quickly just to make sure. So 55 times 50 is 2750, correct. And we have a 60, and now we have 5 more, which is 10. So 60 minus 10, the new length is 50, and we have a 40, and we have a 10 is x, so that's 20. So 40 plus 20 is 60, so that gives us 3,000 in area. So notice the area is going up and up and up, and again the length is 60, but now we add 5 more, which is 15. 60 minus 15 is 45. The width is 40, and we have, again, the increase or decrease is 15, so that's 30 onto that, so that makes that a 70, and 45 times 70 is 3,150. 60, let's say the change is 20, so that makes it a 40. We have a 40 width, and the change is 20, and we double that to make it a 40, so that makes it an 80. Again, we have 40, and 2 times 20 is 40, so the width is increased to 80, so 40 times 80 is 3,200. Again, the width is, the length is 60, and now we go to a 25, so the difference is 35. The new length is 35. 40 was the old width. We got a 25 decrease, but we got to double it, so that's 50 plus 40 makes 90, and 35 times 90 gives me 3,150. And if you notice, as we work this through, that these two are the same. So that means this must be in the middle. So the maximum, as you can see, is 3,200, because these are 3,150 on each side. So 40 and 80, which is what these two are when I work out 3,200. That's just explaining how the problem works. But again, I can solve this problem like this and get to 3,200 without ever thinking about this. Now we have another problem. 600 tickets sold at a concert for $20 each. And it was decided that for maximum revenue, for every $2 increase in tickets, 30 less tickets would be sold. And they want to find the price of the ticket for the maximum revenue. Well, we have the number of tickets that's at the concert is 600, and the price of the ticket is $20. So what I'm going to do, and the way I decide to do it, I let N be the number of increases. That's the way I do it. And let me explain. If you have a $20 ticket and you increase it by $2, then you have a $22 ticket. But in doing so, when you increase it by $2, you're going to lose 30 people going in, so you're going to have a 570. And so you have a certain revenue. So what I'm going to do now is work it out and then do a little chart to show you how this works. But you can see that I have a $2 increase, $22 ticket, and I lose 30 people. So 22 times 570 gives me a certain revenue. And then if I do another increase of $2, the ticket will be 24, and I would have 540 people, and I would get a certain price. So that's where. So let's continue. The maximum revenue R, it's called maximum revenue R, is if I have a $20 ticket and if I charge $2 for each ticket, and N is the number of increases. So if N is 1, I get 22. If N is 2, I get $24 ticket. If N is 3, I get a $26 ticket, etc. And 600 people going to the concert. And for each increase, we will lose 30 people. So one increase, we get 30 off, is 570. Two increases, we get 60 off, we get 540. So this equation will help me get, in terms of the quadratic, it will give me n squared, and you'll see how it works. Here we go. The revenue is 20 times 600 is 12,000. 20 times 30 is 600n. 2 times 600, 2n times 600 is 1200. Minus 2 times 30 is 2n times negative 30n is negative 60n squared. So rearrange that, negative 60n squared plus 600n plus 1200. And again, as you can see, the revenue R is a function of the number of increases. And this is a quadratic. Again, it's a negative A, so you can see that the revenue starts to climb and then it reaches its peak and drops off. So we're looking for what the price of the ticket is. So we'll go N equals negative B over 2A. A is negative 60, B is 600, C is 12,000. So it's a negative of the 600 all over 2 times negative 60, and that gives me negative 600 over negative 120, and that works out to be 5 when you divide. So there's 5 increases. So find the price of the ticket, but we got 5 increases. So the ticket price is, we said the ticket price was going to be right here. So the price of the ticket was 20 plus 2n. So it's 20. The number of increases is 5. So that's 20 plus 10. So that's $30 ticket. So that's $20 and that's $2. So it's a $30 ticket. There's 5 increases, so $10 is added on. You'll have $30 ticket to give you the maximum revenue. And again, let's explain it as we would. Let's go with this chart here. And let's go with the number of increases. This is N. And so now we can go with 20 plus 2N is the price of the ticket. And we can go with 600 minus 30N with the number of people. And we have the revenue. So if I have no increases, then I have 2 times 0 plus 20 is 20. And if I have no increases, then I have 600 people. So I would have $12,000 if I didn't have any increases. But if I have one increase, so 2 times 1 is 2, I would have a $22 ticket. And if I have one increase, 600 subtract 30 is 570. 22 times 570 gives 12,540. If I have 2 increases, 2 times 2 is 20. 2 times 2 is 4, plus 20 is 24. So I add $2 on. And 2 times 30 is 60. 600 take away 60 is 540. And 24 times 540 will give me 12,960. Use your calculator. Now I got 3 increases, so there's another $2 gone on. I can go 2 times 3 is 6 plus 20 is 26, or just add 2. And I got 30 times 3 is 90, so I got a 510, or you can take 30 off. And 26 times 30 is 13,260. And I got another increase, so it's $28, 30 more off, so it gives me 480. So 28 times 480 is 13,440. 5 increases. You got $30 ticket. You got 450 people, and 30 times 450 gives 13,500. And I got another increase, so I got a $32 ticket, and there's 420 people going. 32 times 420 gives 13,440. And if I keep going, but notice that these are the same. And so symmetrical, that means this is the verdicts. The verdicts, if you charge 5 times, which means you got a $30 ticket, you'll make the maximum revenue of $13.50. So that's explaining how this problem works. But I worked out the math of it right here. But this is explains how the problem is really working. Number 3, a soccer ball is kicked from the ground and lands 40 feet from where it's kicked. If its maximum height is 10, find a height 30 feet from where it is kicked. Okay, so let's draw a little diagram. So this is the ground. We have a soccer ball on the ground. So the soccer ball is kicked, it goes up in the air, and then it comes down. Take the soccer ball, with gravity pulling it down, works like a parabola. And again, you notice that there's a maximum area, so it's opening downward. So there's this vertex right there. So if it's kicked at 0 distance, the soccer ball is at 0, and it lands on the ground at 40 feet away, that's the distance, horizontal distance, 40 feet. That means if it starts at 0 and lands at 40, right in the middle is 20 feet. So 20 feet is, this vertex is D and H. D is your horizontal distance along the ground, H is your height. So 20 is in the middle of 0 and 40. And So what we have to do, we have to figure out what my h is going to be. So let's see if its maximum height is 10. Oh yeah. So they gave us at 20 feet, which is halfway, I'm going to have a maximum height of 10. So the maximum height is 10. So that is think of it, that is the y that's in your vertex, like an x and a y. That's your h that's in your vertex, like an x and a y. So we have the distance, or the height, is a, and we have an height, the distance is d, minus 20 plus 10. So notice the vertex is 20, so there's an opposite here. And this is 10, which is the maximum height. So this is the height, this is the horizontal distance. So if we take the point 0, we can take this point here, which is 0, give you 0 height. Or we can take this point, which is 40, giving you 0 height. Either one will do. Let's take 0, 0. The height is 0 when the horizontal distance is 0. So we have negative 20 squared is 400 plus 10. 0 equals 400a plus 10. Negative 400a equals 10. Divide by negative 400. It cancels. A is as a 10. So the zeros cancel. So I get a negative 1 over 40. So the equation is, I'm saying y now, so I'm used to putting down y. The height is negative 1 over 40. D minus 20 squared plus 10. That's the equation that represents the path of this ball. But we want to find a height when it's 40 feet from where it was kicked. So that means D equals, 30 feet from where it's kicked. Gotta be careful. So the height is negative 1 over 40, 30. Take your time. So negative 1 over 40. 30 minus 20 is 10. 10 squared is 100. So we work at the inside and then square it. Now cancel out the zeros. So that gives me negative 10 over 4. That's a negative 2.5. Add on 10. And that gives me 7.5. And it's 7.5 high. So the height at 30 feet, it's going to be 7.5 feet high. And again, there's a few more problems to work on maximum and minimum. And again, when you hear the word maximum minimum, you're thinking about a vertex, and you're thinking about the easiest way is negative b over 2a after you get the equation. If you do not hear the word maximum minimum, then you're working on the quadratic formula. If you like my video, click on the like button, the subscribe button, notification bell. Visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content that's on my YouTube channel. Thank you for viewing my video. Bye-bye.